All right, 24 and 25, we're still factoring. So let's go ahead and rewrite 24 out to the side here. So we have 12y squared plus 17y plus 6. And we're going to go ahead and ask ourselves those two questions. Is there a GCF and how many terms are there? Well, let's see. Is there a GCF here? No, I don't think so. So now we'll go ahead and ask ourselves how many terms are there? Well, we already know how many terms there are, right? It's a trinomial, but just for the sake of getting into the routine of asking ourselves that question, we have 1, 2, 3 terms. When you have 3 terms, that should tell you, all right, I'm going to be using the scissors method or the AC method or trial and error. And in this case, we'll be using the scissors method. So we're going to take the factors of our leading squared term and our constant, and we're going to put the factors of those two numbers into a little chart. And so let's see, the factors of 12, 1 and 12, 2 and 6, 3 and 4, and the factors of 6, 1 and 6, and 2 and 3. And we know that with the scissors method, let's go ahead and try and start with the numbers that are closest together and see if we can get something that works. We're going to go ahead and stack the factors of 12 and then stack the factors of 6. If the 2 and 3 in this combination doesn't work, let's go ahead and flip it and we'll try 3 and 2. We know we're going to be cross multiplying, and again there is the pair of scissors, hence why it's called scissors. So we have 3 times 3 gives us 9, and 4 times 2 gives us 8. Can we in some combination add 8 and 9 together to get a positive 17? Well, yeah, we can, right? If the sign of our 8 is a plus and the sign of our 9 is a plus, well, positive 8 plus 9 gives us positive 17. And you'll recall that whatever sign we put with the cross product is just going to bounce over. So we put a plus with our 9, that plus sign bounces over. If we put a plus with our 8, that plus sign bounces over. And then we can go ahead and group now the factors that we were working with. And so this now becomes 3, and we're working with y, so y, plus 2, plus 2. This here becomes 4y, plus 3, plus 3. And if you'd like, you can go ahead and write those side by side. And there you have it, the factored form for number 24. All right, let's take a look at 25 and see what we have here. We are given 21a squared minus 91a minus 70. All right, well, question number 1, is there a GCF? Well, let's see. I think there is. I think we can take a 7 out of each of these terms, can't we? So if we pull a 7 out, that's going to leave us with 3a squared minus, and 7 goes into 91 13 times, minus, and 7 goes into 70 10 times. So now we've taken our GCF out. Now question number 2 is how many terms are left? Well, 1, 2, oh, and I forgot my variable there in the middle, didn't I? So this is 13a. So where were we? 1, 2, 3 terms. So that tells us we are going to be using scissors, AC, factor by trial and error. Again, let's go ahead and try the scissors method. So we're going to take the factors of our leading term, that squared term there, so 3, factors of our constant, and put them into a chart and list their factors. So let's see. Well, 3 is pretty easy, right? It's prime, so it's only 1 and itself. And then 10, we're going to have 1 and 10, 2 and 5. So again, not too difficult. And as always, let's start with the factors that are closest together. And 3, you don't have any other option, right? We can only use a 1 and 3, so that makes things a little easier as well. And let's try stacking 2 and 5, and if that doesn't work, we'll try 5 and 2. All right, let's see what happens here. 1 times 5, well, that's going to give us 5. 3 times 2, that's going to give us 6. Can I, in some combination, subtract 6 and 5 in some combination again to get a negative 13? No, I don't think so. So the 2 and 5 combo don't work. So let's go ahead and that's why we flipped that last combination, and let's try 2 and 5. And to make things a little clearer, let's go ahead and get rid of all of this since it doesn't work. And now we'll try linking. 1 times 2 gives us 2. 3 times 5 gives us 15. Can we, in some combinations, subtract 15 and 2 to get a negative 13? Yeah, well, I think we can, right? If we, let's see, if we make the 2 positive and the 15 negative, 2 minus 15 gives us negative 13. And again, whatever sign we put with that cross product is just going to bounce over. We put a minus with our 15, so that minus is going to bounce over. And now we will wrap the factors that we were working with. And so this becomes now, let's see, we're working with a, so this will be a minus 5. This will be 3a plus 2, so plus 2. And now let's go ahead and write this for the final time, but do not forget, look, we factored out a 7. That was our first step, right? What's the GCF? So do not forget to include that as part of your answer. So 7, and now the 2 factors of the trinomial that was left after we took out a 7. So we have a minus 5 and 3a plus 2. All right, and there you have it. One question that gets asked a lot by students is this. Does it matter which order you put the parentheses in? No, it doesn't matter which order you put the parentheses in. However, what's inside the parentheses absolutely matters. So you could have written this if you wanted to, 7, and then you could have put 3a plus 2 and then a minus 5. That's perfectly appropriate. So it doesn't matter what order your parentheses come in, it just matters what's inside the parentheses. That's what matters. All right, 24, 25 in the bag. Let's go ahead and take a look at 26 and 27. Hopefully the scissors method is becoming a little more comfortable for you as you do more of these.